请那个 Michael Pan 为我们介绍说 Cloud Computing 在建制的过程中，你可能可以选择什么样的 Open Source 软体，以及说可能你会有什么样，欢迎大家在过程中提一些相关的问题，这样子。好，那我们就掌声鼓励，欢迎 Michael Pan。
Hello. Hi, everybody. 所以我先讲一点中文。我今天讲题目是会再用英文来讲，但是等一下有问题的话，欢迎问中文，那我可以尽量回答。So today, the topic we're going to talk about is open source software for building a private cloud. My name is Michael Pan. I'm the CEO and founder of Nefosity, an introduction about me and my company. I have over 10 years experience working on high-performance computing, which includes distributed, grid, and cloud at various companies. Earlier this year in March, I started Nefosity, which is the company. Nefosity develops cloud computing platform for enterprises. And back in June at Structure 2010, which is probably the largest cloud computing conference, annual conference, we were showcased as one of the 10 most promising startups of 2010. Okay, so the question is, what is behind the cloud, right? So we all use a lot of cloud, different cloud applications like Twitter, Gmail, Flickr, Facebook. But we don't know exactly what's happening behind the scenes. And the reason we want to know what's behind the scenes is if you are one of those if you're trying to develop a SaaS application and you require elastic compute resources, and you want to deploy in the cloud, but you can't use a public cloud like Amazon because of security or performance requirements. So you want to use open source components in your cloud. So the question is, what's available to you? So why not use Amazon? Well, EC2, Amazon's EC2, which is more specifically dynamic provisioning, that's the capability provided by EC2, is only one part of the equation, right? The core is dynamic provisioning, but it doesn't do other things, which we'll talk about later. And also EC2, it's not open source. It's just a service that's provided. Even if you were to use EC2, you need a machine image to run on. So what's the software that you're going to install on this image? And then we're going to also look at what are other alternatives for EC2, open source ones. And if, in case you don't know what dynamic provisioning is, that's the definition there. Just, you can request compute nodes on demand. So what about Hadoop? I added the slide because in Taiwan, when you talk about cloud computing, everyone talks about Hadoop. But again, Hadoop is really only part of the equation, right? Hadoop core provides for MapReduce, and then HDFS provides for data management, right? But then there are other parts that are missing, such as how do you control your Hadoop jobs? And the other question is, what alternatives are there to Hadoop? Because as in our Bird of Feathers last night, I think we all agreed, the attendees there will all agree that Hadoop is not the highest performance, it doesn't have the highest performance functionality. Okay, so looking at the cloud computing stack, I sort of broke it out into three major sections. In each of those major sections, you have to make considerations about components within them. In infrastructure, we have hypervisor, dynamic, so we'll get into this later, actually. So the three major ones are infrastructure, platform, and cluster management. So before we go even further, a disclaimer. I'm really only going to mention about open source offerings that have been released, with one exception, and I'll mention that later. I'll present what's available, but not necessarily how to adopt or implement them, because that will actually take days, even months to talk about. The lists may be incomplete because there's so much open source out there, and hopefully, this will just get you started if you're looking for such things. And last, there's going to be some hand-drawn graphics. I'm not very good at using, PowerPoint, so you'll see some hand-drawn ones I scanned in. Okay, so looking at infrastructure, the infrastructure is really composed of three main things. You have a hypervisor and virtual machine. You have dynamic provisioning functionality, and you have the operating system. So if you look at the image here, at the very bottom, I wrote the M, so that's the actual hardware that you have, right? And on top of that hardware, you're going to have a hypervisor. That's the HV, right? And then that's sitting on top of the hypervisor. You have the dynamic provisioner, which is going to use the hypervisor to provide you with virtual machines. That's the VM. Okay, and on top of those virtual machines, you have the operating system. Okay, so Amazon's EC2 is really only the dynamic provisioner, right? It doesn't do any of the other stuff. And so today we're going to look at this whole thing here. Okay, so hypervisor virtual machine. What is it? Well, the hypervisor provides for hardware virtualization, and it allows you to run multiple virtual machines on a single physical machine. So these are some of the open source offerings available. QEMU, or QEMU, however you want to pronounce it, is the virtualizer itself. Then you have two hypervisors, KVM and Zen. And what they do is they take QEMU and then provide a virtualization functionality. You also have VirtualBox, except that's really only for the desktop usage. It's not it can be adopted for server usage, which is what we're really talking about when we talk about cloud computing. But currently, you can really only use VirtualBox on the desktop. Okay, so then dynamic provisioning. It allows you to allocate and deallocate compute resources on demand. You get the compute resources when you want, and the provisioner reclaims it when you release them, and you say you don't want them anymore. Available open source software include Eucalyptus, OpenNebula, Hazia, and Condor. And so those are the three that are released. And I'm mentioning Elaster because of T-Cloud, CC Lien here. He's been so helpful with the conference, so I thought I should mention it. They're about to come out with it, right, CC? Okay, so next, operating system. So the operating system is actually the interface between your software and the underlying hardware, right? And so in cloud computing, these operating systems are stored as machine images. They're just single big files that are loaded or distributed to the local the physical machine on demand, and then used by the hypervisor to boot into memory. You can think of it, with Ubuntu, the live disk, same thing, right? Except that it's not a CD, it's actually just a single file. Obviously, with operating systems, you have various Linux distributions: Ubuntu, SUSE, Fedora, CentOS. Generally, I think people generally use like Ubuntu and maybe Fedoras and CentOS. Ubuntu is really easy to use mainly because they've created an entire cloud distribution software around them. You can also use BSD, but that's really only on VirtualBox, which is for desktop. Okay, so we've talked about the infrastructure. So now we're going to talk a little bit about the platform. In the platform, there's four main things. There's data management, there's MapReduce, workflow management, and messaging. And so if you look at the picture here, well, I've tried to show like how they stack up on each other, right? So at the very bottom, you have so the left and right are your nodes, right? And at the bottom, you have the virtual machine or the operating system. And sitting on top of that, you have the database management capabilities. And on top of that, you have the MapReduce capabilities, because the MapReduce takes the data and computes it. Then you have the workflow management on top of that, which allows you to control your MapReduce jobs, but also your non-MapReduce jobs. And then on top of that, you have your application, right, that uses the workflow management, uses MapReduce to do whatever you need. And then you look at the center of the image, the way that the nodes communicate with each other, right? It's also it's a network stack, right? So at the very bottom, you have the Ethernet, which is the actual physical hardware. Then you have TCP/IP, which is the transport protocols. And then on top of that, what you really want is a messaging protocol, right? TCP/IP really only allows you to send data over a socket, but if you were to use TCP directly, you still have to do a lot of parsing of the data to figure out where your message begins and where it ends. So messaging should really help you really take care of that for you. So all you really have to worry about in your application is sending a message, discrete messages. Okay, so data management. So we'll go into each of these in a little more detail. Data management allows you to distribute your data across your network. And And not only does it allow you to send that data, but you can also replicate that data across the network. It should help you optimize retrieval to improve your computation time. And it should also optimize your storage requirements. So it really depends. What ultimately comes down to is what are your data requirement needs, right? And so these are some of the considerations as you look at what open source software or any software that you need to implement, that you want to deploy, right? Is it structured, is it non-structured, right? Because in that case, you can look at use SQL or NoSQL. What is the replication degree you want? So how many copies of each data do you want to have on your cloud? Are your files large or small, right? The replication strategy is different depending on whether or not you have small or big files. Do you want consistency or not? Consistency is if you make a change here on one node, do the other nodes see it immediately, or do they see it after a certain amount of time, right? And then there's centralized and decentralized, which is, do you have a master node that's controlling the data management, or is it all distributed? And then you have to also factor in your access patterns. Do you query